All right, happy Wednesday. Sorry I can't be in class today. As I mentioned, I'll be away today. Today, you guys did practice I Learn Math. We will discuss any questions that you may have after going through that and talk about the calculator functions and anything else from that. As you notice in yellow on the right is the schedule for the afternoon. Due to the fact that we only have 33 minutes in each class, it's very quick and with notes and everything else, we are going to go over last night's assignment 144, on sample space and counting principle. That would be the books never written worksheet. We're going to go over that tomorrow. So if you haven't finished it, make sure you submit it, get it done, and submit it before tomorrow because that's when we're going to go over it. You will also have a new assignment 145 on theoretical probability. It's one side. It's really fairly quick. And so you'll have both of those assignments that we will go over tomorrow. And once you finish any of those items, then you may work on this week's iExcel, which I know some of you have already completed and finished and submitted. So keep up the good work. So today we're going to talk about theoretical probability. Yesterday we talked about sample space and counting principle, which shows all the possible outcomes. Now we're going to talk about the probability of something, which is the chances that something happens. And so we're going to kind of fill in these. These didn't come up quite in order, but as we see here, it says, when all the possible outcomes are equally likely, the theoretical probability of an event is a ratio of the number of favorable outcomes to the number of possible outcomes. The probability of an event is written like this. And so we have this P, and then in parentheses is what you want. So in parentheses, when you see that parenthesis, this is what you want. All right. Probability. So theoretical probability is what should happen in a perfect world. It is a ratio, and we can write a ratio in three ways. We'll talk about that in a minute. But basically, in short, what this top is saying is this is what you want. So this is what you want. And what is on the bottom, okay, is always the total possible. So if you're thinking of 10-0, the total possible in the game of 10-0 were 36 possibilities, and what you wanted, as you were playing, is what you would put on top. All right. Now, this is kind of really important. I've kind of starred this in my notes and makes this. This is kind of an important idea, and this is just putting words to the numbers and a couple things as we look. All probabilities are written can be written in three ways. You can write it as a number, okay, which would be kind of this would be a fraction. So it could be 0, 1/4, 1/2, 3/4, 1 are the examples they gave us. Then we have the decimal form. So this is just like when we were in our percent unit, and the final form, which makes the most sense, but quite honestly, when it comes to testing and stuff, a lot of times they put it in decimal or fraction form, but percent form. So when you hear that something has a 0 probability, when we look over here, that means it is impossible. It's never going to happen. On the other hand, when you have a probability of 1 whole or 100%, then it is certain it's going to happen. Obviously, if we head towards the middle and we are at 1/2 or 0.5 or 50%, then you are equally likely that it's going to happen. And then the closer you end up going towards 0, the more unlikely the event is to happen. And the closer you get towards 1 whole or 100%, the more likely. So it's just kind of putting a number, a word to represent that probability as we look at it. So we're going to quickly go through, and today I'm going to make you guys write your probabilities in all three forms just to keep you practicing and making sure you understand, so you can have a calculator easily help you. So we have the word chargers, and we have these letters, and they cut them up and put them in a hat. We want to know what the probability. So when we see this P and then parentheses C, it's saying what is the probability of getting a C. So up there we have 1C. So it's what we want over the total. We count, we have 1, 2, 3, 4, 5, 6, 7, 8 letters. So the probability of getting a C is 1 out of 8. Now, remember to change that to a decimal. We do top divided by bottom. And so on our calculator, we will get 0.125. And to make it a percent, we're going to move that decimal point 2 to the right, and it's 12.5%. So it's pretty unlikely that you would get a C, because obviously you're heading towards 0. Probability of an R. Well, if we look closely, we have 2 R's out of the 8. That would simplify down to 1/4, which quite honestly you should have memorized. 1 divided by 4 is 0.25, or 1/4 of a dollar. And then move your decimal point over 2 would make it 25%. So once again, that would be unlikely to happen. Probability of getting a vowel. Well, we have an A and we have an E. So same as the last question, we have a 2 in 8 chance, which is 1/4, which is 0.25, and 25%. Okay. Probability of not a vowel. This is called a complement. So these are complements, because here I have vowel, and the opposite of a vowel would be not a vowel. So it's going to be the exact opposite. And when you put these two probabilities together, it will always be 100% if you were to add them together, because something will either happen or it will not happen 100% of the time. So in this case, a probability of not a vowel would be, well, C, H, R, G, R, and S. So it'd be 6 out of 8, which would simplify down to 3/4, which is 0.75, or another way of looking at it is 75%. And if you think about it, 75% plus 25% is 100%. So you're either going to get a vowel or a not a vowel 100% of the time when you reach into that hat. All right, the probability of getting an R or an S. So an R, there's 2 R's. There was 1 S in the word chargers, so that probability is 3 out of 8. We divide, 3 divided by 8, going to give us 0.375, and we move that decimal point over 2, and we get 37.5% of the time. Once again, if there are 8 total, this is called a complement. If there are 8 total R's or total letters, and 3 of them are R or S, that means then the opposite would mean that there's got to be 5 that are not R's or S's. And so we would have a 5 in 8 chance. If you add 3/8 and 5/8, you get 1 whole. And if we divide, we get 0.625 using that calculator, and you get 62.5%. Once again, if you were to put those two together, it's going to add up to 100%, because you're either going to get one of those two things 100% of the time. All right, go ahead and flip over to the next side, and we are using a spinner this time. This spinner has numbers 1 through 8 on it. This is asking me for the probability of getting a 3. Okay, there is 1, 3 on here, so 1 out of 8. So a lot of the similarities, because we had 8 letters on the last problem, and now we have 8 numbers. We divide, 1 divided by 8 is going to give us 0.125, which is 12.5%. As we look at probability of an even number, even numbers would be obviously 2, 4, 6, and 8. And so there are 4 out of the 8, which is 1/2 when you simplify. Divide, obviously you should have this memorized, is 0.5. And half of the time would give me 50%. So if we kind of think back, number 7, probability of a 3 would be unlikely to happen because it's only 12% of the time, 12.5% of the time. Probability of getting an even number is 50%, so it is equally likely that it's going to occur. The next question says, probability of getting a number less than 4. Well, numbers less than 4 would be 3, 2, and 1. So there would be 3 out of 8. Once again, we divide. 3 divided by 8, we get 0.375, which is 37.5% of the time. And that is unlikely then because it's less than 50%. All right, we threw this one in here just to make you think about what prime numbers are again. Prime numbers have exactly 2 factors. I want to remind you that 0 and 1 are neither prime nor composite. Okay, the first and smallest prime number is 2. So 2 is a prime number. 3 is a prime number. 4 is not. 2 is the only even prime number, so we don't even have to think about any other even numbers. 5 is prime, and 7 is prime. And then once we get past 8, we're done. So there are 4 prime numbers listed, which out of the 8, which is 1/2 of the time, we would get a prime number. So we're going to be equally likely because it is 50% of the time, or 0.5. Okay. All right, jumping to the next section. Now, if we understand probability, then we can use it to make predictions based on what should happen. This is kind of what, once you knew the probability of getting, for example, a 7 in 10-0, now you would probably change your strategy when you set up your O's on your board. All right, so in this problem, it says the theoretical probability that you randomly choose a red marble from the bag is 5 out of 8. If there are 40 marbles in the bag, how many are red? We're going to set up a proportion. So we're going to think of Jimmy Neutron in this case. The probability of getting a red was 5 and 8. What does that mean? Well, that means the 5 represents the number of red, and the 8 represents the total. Well, we're going to set up a proportion. And what would make it equal? Well, if there's 40 marbles in the bag, it doesn't say 40 red marbles. It says 40 marbles. That's the total number of marbles. And we're trying to find X, the number of red marbles. Now, you can do Jimmy Neutron, but in this case, I see that 5 or 8 times 5 is 40. So I'm just going to do common multiplier, and 5 times 5 is 25. So there would be 25 red marbles in a bag if the probability is 5 out of 8. And there are 40 marbles, then it would have to be 25 out of the 40 are red. All right, so how many red would there be? So as we try over, it says you try. How many red would there be if there's 64 marbles in the bag? So once again, we're going to use the probability that we started with, which was 5 out of 8. Once again, labels are helpful. This is the number of red. This would be the total. So in this case, the total is changed. We now have 64 marbles in the bag, so 64 would go on the bottom, and we're going to put X up here at the top. And we're going to do our common multiplier again in this case, because that makes life a whole lot easier. So 8 times 8 is 64, and 5 times 8 is 40, so X equals 40 red marbles in this case. All right, last example. All right, so we have this bobblehead, and it says the theoretical probability of winning a bobblehead when spinning a prize wheel is 1 in 6. The wheel has 18 sections. For A, it's going to ask us how many sections does the bobblehead have a prize. So in this case, it's 1 out of every 6. Well, the 1 represents the number of wins, and this would be the number of things that are on the wheel. So in this case, if there are 18 sections on the wheel, then that would be the total number of sections. And once again, we will use, I'm going to use common multiplier because 6 times 3 is 18. So I'm going to do 1 times 3. And that means there would be 3 sections that are winners for bobbleheaders. All right. If we spun the wheel 540 times, how many bobbleheads should we expect to win? Well, if you're going to win 1 out of every 6 spins, that's what that means. So once again, this is the wins over the total. If you were to spin it 540 times, how many times would we expect to win? Well, this is where we can go ahead and use Jimmy Neutron. So in case you have forgotten, we'll do it once here. So this is 540. This is 6x. We're going to divide both sides by 6, and that's going to give me, 90 wins. So this is going to be 90 wins in this case. Okay. All right. So at this time, you are going to get your assignment, and it's not assignment 140. My bad. This is assignment 145. Okay. And you will, I want you to write each one in fraction, decimal, and percent form. You're making predictions down here at the bottom. So down here at the bottom is where you guys are going to use your proportions. And up at the top, you're just strictly writing what is the probability of an event happening. Once again, if you didn't finish assignment 144 or remember to submit it, make sure you get that submitted and complete this assignment and get it submitted.